Hello, it's dumplet here. Here's an item on algebra. K is a real number such that the following equation is true. The floor, or the greatest integer less than or equal to 18 divided by 8 minus k, that's equal to k. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, I think this is a very straightforward question that involves the floor function because we could get a lot of information actually on k. So just a bit of application on the floor function. Well, k is the result of this floor function, and because it is called the greatest integer function, k is going to be the greatest integer less than or equal to 18 divided by 8 minus k. So with that information alone, k would definitely be an integer. Right? That's going to be step one. Now, the other thing to note about the floor function is that, well, since we know that the floor, or the greatest integer less than or equal to the 18 divided by 8 minus k, that's going to be greater than or equal to its floor, which is k, and it must be less than the next integer. So that's a very nice property, actually. So whenever you have a floor, let's just say floor of a, let's just say we got this to be k, or let me use a different letter, let's just say it's m, then a would have to be between m and m plus 1. So it's going to be greater than or equal to m, but less than m plus 1. So this is a nice thing that you could use for the floor functions because it gives you a bound. So for questions that involve the floor functions, it's going to be a lot of bounding, taking a look at the integers, and something like that. Now, we do have this inequality. I'm just going to focus on the left and the right one. I'm going to split them. The first one is going to be this. And alright, this is a rational inequality, so I'm just gonna do the standard way to on solving them. Here's another video on solving rational equations. Click this link, and that's going to give you the other example on rational inequalities. Now, I'm just gonna move the k to the other side, so I'll have minus k times 8 minus k divided by 8 minus k, and this would be greater than or equal to 0. And putting it into one fraction, I'll have 18 minus 8k plus k squared divided by 8 minus k. That's going to be greater than or equal to 0. Now, there's one funny thing actually. The numerator, right? The numerator, I can write this as k minus 4 squared plus 2. So in fact, well, this thing is always positive because, well, it's 2 more than a perfect square, and k is a real number. So the numerator is always positive. So a positive number divided by 8 minus k, it's going to be greater than or equal to 0. So, well, it can't be 0 because the numerator is positive, but surely this 8 minus k, that has to be positive as well. So 8 minus k must be greater than 0. That's going to give us k to be less than 8. And that's going to be one bound for the question, which is pretty good. Alright, next let's try to focus on the next part. K plus 1 being greater than 18 divided by 8 minus k. Same trick, let's try to do the standard way. I'm going to put the k minus 1 to the other side. So we're going to have this one. And then I'm going to write the k plus 1 now as 8 minus k times k plus 1 divided by 8 minus k, with the goals of writing the expression in terms of just one fraction. So it's gonna be 18 minus 8k minus 8 plus k squared plus k. Alright, and let me just simplify the numerator. So I'll have 0 to be greater than k squared minus 7k plus 10 divided by 8 minus k. Now, take a look. We have 8 minus k to be greater than 0 from the first one. We could use this to our advantage. So 8 minus k is going to be positive. So if I multiply both sides by 8 minus k, the inequality sign will not change the direction. So that's good. So I'm going to multiply both sides by 8 minus k. I'll have 0 being greater than k squared minus 7k plus 10. And if I solve this inequality, I can factor the right hand side as this one, and I could solve the inequality. This is just a quadratic inequality now. I have two critical points, 2 and 5, so I know that the values of k must be between 2 and 5 exclusive. So just simply use the knowledge in quadratic inequalities over there. Again, combining with the fact that k is an integer, we just have to get integer values for k that's between 2 and 5 exclusive, and we could just kind of see that, well, those two values are k equals 3 and 4, and these two are in fact the answers. Now, just to kind of show you that both of them work, because we didn't do any much of checking, just to make you guys convinced that they do work. So if k equals 3, we're going to have the floor of 18 divided by 5. That's going to be 3, and that's good because 18 divided by 5, that's 3.6, so that's definitely correct. And then for k equals 4, the floor of 18 over 4, that's going to be equal to 4. Checking this value, that's going to be exactly 4.5. And the floor of 4.5, that's going to be indeed equal to 4. So these two values of k will be our final answers. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.